Hi, my name is Rushan. I'm from BMMH 1 Section 2. For our solid mechanics subject, we have done torsional loading evaluation from an actual structure, and the structure we have chosen is a T-Luck wrench. Before we go any further into the subject, let us look at the introduction. Torsion. Well, torsion is the action of twisting or the state of being twisted, especially at one end of an object relative to another. Okay, for example, when an object is twisted, torsion occurs at one point and another point. Another point is straight. Okay. Next, what is torsional loading? Torsional loading is the load that imparts the turning moment or the torque. It is also known as a moment that twists a structure, and while in layman's terms, it is also known as torque. Shear stress. Well, shear stress is a force tending to cause deformation of material by slippage along a plane parallel to the imposed stresses. What is moment of inertia? Moment of inertia, well, it is also known as the mass moment of inertia, angular mass, second moment of mass, or rotational inertia. A rigid body is a quantity that determines the torque needed for a desired angle. Well, when you're turning or twisting an object, there is a angle where the object twists at one point, and this is also known as the moment of inertia. Well, lastly, before we go any further, let us see what is factor of safety. Factor of safety, or commonly known as FOS, well, the load carrying capacity of a system beyond what the system actually supports. And in many designs, factor of safety plays a very vital role. For example, for aerospace, factor of safety is there, and for automotive, factor of safety is there. And no matter how you design a product, or you design a product, or what do you say, you would to build a product, okay, factor of safety plays a very important role. And factor of safety shows that when a force is applied, and even though it exceeds upon maybe 10 to 20%, the object still works. And for example, although I'm stretching this straw, but although I'm stretching this straw with very high force, still the straw does not break. And yes, factor of safety plays an important role here also. And further into this topic, we shall discuss regarding the factor of safety, moment of inertia, shear stress, torsional loading.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Muhammad Sharif. My metric number is B0920103339. Today I would like to explain about problem statement and idealized model for our group project. First, we will go to the problem statement. By studying the Lagrange as our idealized model for our mini project, we are able to calculate the torsional load and torsional force produced. Other than that, we will be also to get the angle of twist along with the safety factor of the model. Next, we will go to the idealized model. This is our model for group project. This is the Lagrange. This Lagrange have 0.013 meter diameter and 0.23 meter length. This material is from steel cast and have G 120 GPa. We also apply same force at this point and this point, which is 70 Newton. That's all for me. Thank you.
Assalamualaikum and hi, my name is Muhammad Akaiman bin Adumanap. My metric number is B0920104000. Our objective is first to perform the calculation of shear stress of a circular shaft subject to torsional loading and to determine the equation of equilibrium EOE, yield shear strength and modulus of rupture in shear, and to get the theoretical data of the model specimen. And our background is A lug wrench is the name for a type of socket wrench used to loosen and tighten lug nuts on automobile wheels. Lug wrench may be L-shaped or X-shaped. The form commonly found in car trunks is an L-shaped metal rod with a socket wrench on the bend end and a prying tip on the other end. The prying tip is mainly intended to remove hubcaps or wheel covers that may be covering a wheel's lug nut.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imam bin Razak and I will explain about the calculation for our project. From the FBD, we can see the length for the wrench is 230 mm and the wrench is made of steel with a shear modulus of 120 gigapascal. So we assume that the force applied to the wrench is 70 Newton. Since the summation of Fy equal to 0, so the F2 will be equal to F1, which is 70 Newton. After that, we calculate the couple moment and the torque, and we get 32.2 Newton meter. To calculate the maximum shear stress, we need to find the polar moment of inertia. So we get the polar moment of inertia, we get 2.804 nanometer root of force. So from there we can calculate the maximum shear stress and we get 78.64 gigapascal. By using the formula TL over JG, we get the angle of twist which is 0.044 radian, and after we convert it to degrees, we get 2.521 degrees. That's all for me. Thank you.
Hi, my name is Muhammad Amirfan bin Muhammad Shukri. Nama metrik B0920100491. I will present my part is discussion and conclusion. For discussion, our evaluation of idealized model from actual structure, we have choose the lug range. We were able to get the data for the torque, polar moment of inertia, maximum shear stress, and angle of twist. With a force of 70 Newton applied, the theoretical data we have obtained were torque is 32.2 Newton meter. Moment of inertia is 2.804 nanometer root of 4. Maximum shear stress is 74.64 gigapascal. Angle of twist is 0.044 radian or 2.521 degree. The material of the wrench is steel plate with chromium Hg, which means shear modulus of 120 gigapascal. We are able to assume based on the uses of the tool, the safety factor should be in the range of 2 till 2.5 due to the condition of loading users. And for the conclusion is, we are able to gather data to analyze the model to develop relationship between angle of twist, moment and shear stress. And lastly, we can apply our skill to real world scenario to find calculation data. We are able to study the effect of torsion on a model and shear stress produced in a model. That's all from me. Thank you.